Group 7 में moving forward, thermal stability of hydrogen halides. Hydrogen halides are represented by HX, that's a symbol. Hydrogen will react with chlorine in the presence of UV light, and then hydrogen chloride is formed. And this reaction is also called a photochemical reaction because you need light energy. Whenever light energy is required, the reaction undergoes a photochemical reaction. When hydrogen is treated with iodine under a certain condition, then hydrogen iodide is formed. If you notice, there is an irreversible sign here. If you notice here, there's a reversible sign here. So thermal stability of hydrogen halides will decrease from HF to HI. This is because atomic size of the halogen increases, hydrogen to halogen bond length increases, and when bond length increases, the bond gets weaker. This decreases the bond energy value, and hence decomposition takes place at a low temperature. Hot glass rod is used for the thermal decomposition because it provides activation energy for the reaction. Please understand that while iodine has violet vapors, black iodine can exist as violet vapors, a brown solution, and as a black solid. Please understand, Kalina, the acid strength. The strength of acid cannot be determined on the basis of dilute or concentrated solution. The ease of with which hydrogen ions can be donated, right? Strength of acid depends on the extent to which acid is ionized, meaning to say how easily hydrogen is protonated or ionized. Easier the ionization, stronger the acid, which is why lower pHF value. As you move from HF to HI, the bond becomes weaker, right? HI will easily ionize, therefore HI is a stronger acid than HF. Acid strength of hydrogen halide increases from HF to HI because covalent bond is weaker as you move down the group. So ionization in aqueous medium takes place easily. Reaction of halogens and halides. You will have to learn all of this. That reaction, a halogen when reacts with NaOH. Please understand that this is cold condition. Sodium halide and sodium halate 1 are formed. You will have to learn these equations. X could belong to any of these 3 elements. Please understand that the halogen has 2 different valencies here, and when a compound, whenever an element or a compound undergoes oxidation and reduction simultaneously in a reaction, that is called a disproportionation reaction. In terms of hot conditions, you need to understand that they again you have NaX, but there is sodium halate 5, right? And there is a difference in balancing, so please check that out as well. Number of moles are different. Displacement or redox reaction. Displacement reaction depends on the reactivity of halogen, and the reactivity is as follows: most reactive, least reactive. A more reactive halogen can displace less reactive halogen from its salt. Cl is more reactive than iodine if you check the table out. Therefore, Cl will displace it. You are asked to write the observations. Chlorine is a yellow-green gas, so the yellow-green color fades away, and violet vapors are formed, or a black solid is formed, or a brown solution is formed, whatever the state is given to you. Similarly, this is, let's say for example, HF was reacting with chlorine. Now, checking of the reactivity, chlorine is not more reactive. Fluorine is more reactive. So there will be no reaction because chlorine cannot displace a more reactive element, which is fluorine in this case. So reaction of halides with concentrated H2SO4. Please understand that concentrated H2SO4 is not a strong enough oxidizing agent, which is why it can't oxidize F minus and Cl minus. Hence, it is used as an acid with them, right? So NaCl H2SO4 will give you an acidic salt and an acid. NaCl plus H2SO4, 2 moles of NaCl would work off and give you a neutral salt plus HCl. HCl has steamy or misty fumes. Again, MgCl2 gives you H2SO4. However, with bromide, if you see, H2SO4 will act as an oxidizing agent because bromine is oxidized. If you check it out, for iodine, it is again acting as an oxidizing agent. So I've mentioned it here. From fluoride to astatite, ionic radius increases. Nucleus to electron attraction decreases, which is why loss of electron takes place easily, hence reducing power of halide ions will increase. Halogens are oxidizing agents, whereas their corresponding halides are reducing agents. Reaction of halide with silver nitrate, again, just learn it off, right? With the silver nitrate, it is giving NaCl with silver nitrate will give you AgCl. You will have to learn this question because this comes in your organic chemistry as well. AgCl is a white precipitate which is insoluble in water, right? And if I'm putting in excess ammonia, it will dissolve. These were cation and anionic reactions that you used to learn for ATP and O levels. With dilute NH3, it is soluble. With concentrated NH3, it is still soluble. For bromide, you need to understand that there is a creamy precipitate. And bromide with dilute NH3 is partially soluble, whereas with concentrated NH3, it is completely soluble, giving a colorless solution. For iodide, it is giving a yellow precipitate, and you can hence conclude that the color intensity increases down the group. Because with chloride, AgCl was a white precipitate, AgBr was a creamy precipitate, AgI is a yellow precipitate. In the above complex, two dative bonds are formed between ammonia and silver. Ammonia donates its lone pair to its silver metal ions, which is why ammonia behaves as a ligand. Right? Ligand is an electron pair donor. Right? Here our group 7 concludes. Periodicity and period 3 elements. Chlorides of period 3 elements, sodium with chlorine forms NaCl, right? A yellow-green gas, the yellow-green gas would disappear. Sodium burns with a yellow-orange flame. You need to learn all of this, by the way. A white solid is formed. Bonding is ionic and structure is giant lattice. The types of forces are strong electrostatic attraction, melting point and boiling point are high. Solubility, it is water soluble, giving a neutral solution of pH 7. NaCl, when reacted with water, breaks down into Na plus and Cl minus ions. Magnesium reacts with chlorine, right? And a yellow-green color fades away. Again, a white solid is formed. The bonding is ionic, structure is giant lattice. Types of forces, strong electrostatic forces, melting point, boiling point are high. Solubility, water soluble, giving an acidic solution. Aluminium would again form a white solid. Yellow-green gas will disappear. Bonding is covalent. Structure, molecular. Types of forces, weak van der Waals forces. Melting point and boiling point is low. Solubility, it will hydrolyze. Basically, aluminium has an empty pz orbital, and as a result, white precipitate and misty fumes of HCl are formed with a pH value of 3. Moving forward, AlCl3 with H2O gives you AlOH3 plus 3HCl. AlCl3 with more water content forms a complex solution. Silicon will react with chlorine to form silicon chloride. It is a colorless solution, colorless liquid. Yellow-green gas again disappears. Bonding is covalent. Structure is molecular. Types of forces, van der Waals forces, melting point, boiling point is low. Solubility, again it hydrolyzes because of the presence of empty d orbital and forms an acidic solution. SiCl4 plus 4H2O gives you SiOH2, SiOH4 plus 4HCl, and so on. Phosphorus reacts with chlorine to form PCl3, which is phosphorus 3 chloride, or it could also form PCl5, phosphorus 5 chloride. It is a colorless, PCl3 is a colorless liquid at RTP, PCl5 is a white solid at RTP. Bonding is covalent, structure molecular. Oxides of period 3, again, sodium reacts with oxygen to give you Na2O. Please understand that sodium will burn with a yellow-orange flame and a white solid is formed. Every single thing in here has to be learned. Please understand that as metallic oxides are basic oxides. Since this was an ionic bonding, there is a giant lattice involved. It's a basic oxide, it will react with an acid. Na being a group 1 metal floats on water and burns explosively with orange flame, and it is highly exothermic. Bubbles of gas are given off. Magnesium, on the other hand, burns with a brilliant white flame. The bonding is ionic, the structure is giant lattice, melting point and boiling point are high because of strong electrostatic attraction. Aluminium burns with oxygen to form Al2O3, burns with a silvery white flame. The bonding is ionic, significant covalent character is involved, and so on. As you move from magnesium to aluminium to silicon, you need to understand that the boiling point of the oxides is increasing. Silicon burns with a yellow flame. You need to learn that the structure is giant lattice. Melting point and boiling point is high because of strong bonding. Phosphorus will burn off to give you either P4O6 or P4O10. This one is a white solid with and burns with a pale yellow flame. Right? This goes on for both, by the way. Non-metallic oxides will have an acidic behavior. Sulfur burns with oxygen. And would produce sulfur dioxide, which then further reacts to form sulfur trioxide. Sulfur is an acidic oxide and therefore reacts with an alkali to form a salt, and in some cases water. Chlorine, again, chlorine when reacted with oxygen will form chlorine 1 oxide or chlorine 7 oxide. Both of them will both of them will then react with water to give you chloric acid. Now, chloric acid is basically used in swimming pools and all to disinfect. So, electrical conductivity of period 3 elements, sodium, magnesium, aluminium being metals. This one donates 1 electron, this one donates 2 electrons, this one donates 3 electron. Will have their electrical conductivity increasing. After that, silicon has somewhere in between because it is a metalloid or a semiconductor, and phosphorus to argon are non-metals and therefore the value is less. Melting point keeps on increasing. Silicon has a giant structure, so because of strong covalent bonds, it has a high melting point. Phosphorus to argon, your covalent bonding increases such that phosphorus is P4, sulfur is S8, and therefore strength of van der Waals forces increases. Therefore, boiling point इस तरीके से would increase. Atomic radius का ग्राफ यार, सोडियम 1 इलेक्ट्रॉन लूज करेगा, मैग्नीशियम 2 इलेक्ट्रॉन लूज करता है, and so on. Your radius keeps on decreasing. When moving from Na to Cl, shielding remains the same, while nucleus to electron attraction increases, which is why atomic radius decreases. The ionic radius, sodium loses 1 electron, magnesium 2, aluminum 3. Si can lose 4 electrons, and therefore the ionic radius decreases. Whereas these form negative electrons, which is the reason, negative charges, which means that they gain an electron, and since they gain electrons, their ionic radii are huge. Ionization energy was already done before. pH of higher oxidation state. I told you that all the metallic oxides would produce an acidic oxide, whereas non-metallic oxides these ones produce alkaline oxides, whereas the non-metallic ones produce acidic oxides. Moving forward, nitrogen and sulfur. Nitrogen belongs to group 5, and so it contains 5 electrons in its valence shell. Sulfur belongs to group 6, so it contains 6 electrons in its valence shell. Both show variable oxidation state in their molecules and ions. Nitrogen contains triple bonds, so it has high bond energy values, which is why it is inert and unreactive. You must have heard about nitrogen ice creams. The fact that they have triple bonds amongst themselves, which makes them inert, and therefore it is edible. Doesn't cause any problems when you eat them. Lab preparation of ammonia, thermal decomposition of ammonium chloride is possible. Your reagent is ammonium chloride. State is it is a sublime solid. A reversible and an endothermic reaction. Ammonium chloride, when heated a bit, right, and passed through a mineral wool, would release of ammonia gas and HCl somewhat like this. right? Alkaline gases will shift the color. Alkaline gases shift the color towards the blue end, and therefore I have highlighted red litmus paper here because alkaline gas is NH3 here, which is what we are trying to test. If the red litmus changes color to blue, meaning to say there is ammonia present. The rate of diffusion is faster because of the low MR of NH3, and it changes the color from red to blue. The rate of diffusion of HCl is slower because of its higher MR, so it changes the litmus paper from blue to red. Acids tend to change the color towards red. Alkalis or bases change the color towards blue. Moving forward, ammonium chloride with alkali or basic oxide. These are a few set of reactions. Ammonium chloride has acidic properties, so will react with an alkali and therefore produces salt, water, and ammonia gas. When any ammonium salt reacts with any base or basic oxides, when damped, then NH3 gas is obtained. Physical properties of ammonia: it is a gas at RTP, it is soluble in water, and it is lighter than air. Since it is lighter than air, it can be collected through downward displacement or upward delivery. Upward delivery looks somewhat like this. Drying agents used are anhydrous CaCl2 or calcium oxide. Chemical properties of ammonia: it will react with HCl to produce ammonium chloride. Right? This is an acid-base reaction. NH4Cl will have ionic bonding between NH4 plus and Cl minus. There's covalent bonding between the NH3 molecules already present, and there's a dative bonding in here as well. NH3 donates its lone pair to give ammonium ion and therefore acts as a base. It is used as a fertilizer. Some reactions involved are NH3 reacting with nitric acid to give you ammonium nitrate. It is used as an explosive and a fertilizer. Ammonium hydroxide reacts with sulfuric acid to give you ammonium sulfate and water. Ammonium sulfate is used as a fertilizer. NH3 reacts with SO3 and H2O to give you ammonium sulfate again, and so on. Uses of NH3: degreasing agent, we need to say drying agent, fertilizers, explosives, solvent. Hydrogen is a compound N2H4. Looks somewhat like this. The angle is 107 degrees. Its state is liquid at RTP, and it is very soluble in water because of hydrogen bonding present. Hydrogen when bonded to a more electronegative element having a lone pair. More electronegative elements are nitrogen, oxygen, and fluorine. Geometry is trigonal pyramidal nature, Lewis base, and reaction with acid is somewhat like this. It is used as a rocket fuel and burns with oxygen to give you water plus nitrogen gas. Oxides of nitrogen, dinitrogen oxide, right? It is not a pollutant. It is formed by thermal decomposition of NH4NO3. The equation is important. It is used as an anesthetic, that is used as an anesthesia for patients. Nitrogen monoxide, its structure is somewhat like this. By the way, oxygen forms a dative bond. Equation is important. Right, and nitrogen dioxide has a charged resonance. By the way, nitrogen monoxide, it is a pollutant as well because it causes lung irritation. NO2 is a pollutant because it causes global warming. Equations again are important. Whenever a reaction in which an element undergoes oxidation and reduction both would be called a disproportionation reaction. Right? By the way, this reaction we have done before. NO2 when reacts with SO2 gives you SO3 plus NO. This NO further being an intermediate reacts with oxygen in the atmosphere to form NO2. If you check it out, NO2 is acting as a catalyst here. Catalytic converters are used in cars. They are used to convert oxides of nitrogen and other unburned hydrocarbons, which could be harmful pollutants into carbon dioxide, water, and nitrogen. There's a mesh of platinum and rhodium catalyst, which increases the surface area. By the way, your carbon monoxide, which is poisonous, reacts with oxygen to form carbon dioxide. This is a material that is used or attached with the silencer in cars. It converts nitrogen monoxide and carbon monoxide into carbon dioxide and nitrogen gas. Moving forward, lab preparation of SO2. You use sodium sulfide and concentrate H2 HCl. Your products are NaCl, H2O, and SO2. Somewhat like this. SO2 is a gas at RTP density denser than air. It is soluble in water and is used as a drying agent in the form of concentrated H2SO4. Its uses involved, it is used to bleach wood pulp and then used to make paper. It is used as a food preservative because it prevents oxidation of food. Sources are burning of fossil fuel, volcanic eruption, coal-fired power station. To control SO2 in the atmosphere, flue gas desulfurization plant, which contains powdered calcium carbonate, that is marble chips. Flue gas desulfurization involved these two steps. Flue gases are your waste gases, right? And you need to not allow sulfur dioxide to escape into the atmosphere. So you basically reacted with powdered calcium carbonate, which makes a salt. Environmental consequences of SO2, it causes global warming, acidic rain, and corrodes limestone building. Global warming is because of CFCs, SO2, NO2, and carbon dioxide. All these greenhouse gases would cause global warming because they trap an infrared radiation and then re-emit it at a later time. Meaning to say, let's say, had they trapped it today, they will then release it when there are winters. Because of all of this, winters do not feel so cold and summers feel extremely hot, thereby giving an indication about global warming. Haber's process we have done before. The conditions involve 450 degrees Celsius, 200 atmosphere pressure, and low temperature and high pressure is required so that the equilibrium favors in the product direction. These are compromised conditions because under such conditions we get optimum yield and high rate.